video, we're going to take a look at some of the skills required to answer a sequences and series question. So the first question here says the following three terms are in an arithmetic sequence. So arithmetic sequence, I'm writing down the formula for that first of all, which is going to be term 2 take away term 1. The difference between those two will be equal to the difference between the next two. Then I'm going to fill them in. Term 2 is the second term, which is Q. Then I'm going to have take away term 1, which is P, will be equal to term 3, which is 1/4, take away term 2, which is going to be Q. And the question wants me to write Q in terms of P. So what I would like here from this question is Q equals something with a P in it. So I'm going to rearrange this formula. I'm going to add Q to both sides and I'm going to add P to both sides. So I get 2Q is equal to 1/4 plus P. I now need to divide everything in by 2. So I'm going to have 1/8. So a quarter divided in 2 further is going to be 1/8 plus P over 2. And that is Q in terms of P. Right, the next one, the following three terms are in a geometric sequence. And again, it's write Q in terms of P. So I'm going to have my formula for that. It has a common ratio, which means that term 2 divided by term 1 will be equal to term 3 divided by term 2. Now I'm going to fill it in. Term 2 is 1/4 all over term 1, which is P, which will be equal to term 3, which is Q, all over term 2, which is 1/4. Now what I'm going to do is I'm going to simplify this out further. So what I'm going to do first is I'm going to multiply both sides by 1/4. So I'll get 1/16 over P is equal to Q. I'm then going to get rid of my P here by multiplying that up. And I'm going to have PQ is equal to 1/16. And what they want me to find is to find Q in terms of P. So I would like to divide the P out so that I get Q equals 1/16. And then I'm dividing by P now as well, which will be 1/16P. The next one says, using your results from part 1 and part 2, find the values of P. So they're asking me to basically do a simultaneous equation. I have two unknowns and you have two equations now. Now use them. So here I found out that Q was equal to 1/16P, and above previously I found out that it was equal to this. So if Q is equal to both of those things, and we're talking about the same P and Q, which we are, I'm going to say, right, Q is equal to this, Q is also equal to this, let's let them equal to each other. So I'm going to have 1/8 plus P all over 2 is equal to 1/16P. So what I'm going to do is I'm going to multiply every single thing through by 16. That's going to let me get rid of some of these fractions here. So if I multiply 16th by 1/8, I get 2. Plus, if I multiply 16 by P over 2, I'm going to get 8P. And if I multiply 1/16P by 16, I'm going to be left with 1/P. I then definitely want to get rid of that P on the bottom there. It's dividing, so to get rid of it, I'm going to multiply everything through by P. So I get 2P plus 8P squared plus 1, or equals plus 1, apologies. I'm now going to bring everything to one side because that's a quadratic. So I'm going to have 8P squared and I'm going to have plus 2P and then I'm going to have minus 1 is equal to 0. And then I'm going to solve this. It's not going to factorize nicely, I don't believe. So I'm going to use the minus B formula to do that. So we're going to have minus 2 plus or minus the square root of 2 squared minus 4 by 8 by minus 1 all over 2 by minus 1 Tidying this out, I'm going to have minus 2 plus or minus the square root of 4. And then I'm going to have 4 by 8, which is going to give me 32. By minus 1 is going to give me plus 32. And then I'm going to have all over 2 by minus 1, which is minus 2. I'm going to keep tidying this out, so I'm going to have minus 2 plus or minus the square root of 4 plus 32 is root 36, and it's going to be all over minus 2. Tidying this out further, I'm going to have minus 2 plus 6 all over minus 2, or here I'm going to have minus 2 minus 6 all over minus 2. I'm going to move this all up because I'm not anywhere near finished yet, because this is just the value of P that I'm working out. I still have to get Q as well, do I? Or it just says, using your results, find the values of P. Okay, so I don't need to find Q, they just want me to find the values of P. So we're nearly there. Minus 6, or minus 2 plus 6 is going to be plus 4, divided by that is going to give me P is equal to minus 2. Over here, I'm going to have minus 2 minus 6 gives me minus 8, divided by minus 2, P is equal to 4. So there's my two values. Just a little bit of algebra. The only real sequences and series part there was knowing what to do when it's geometric, what to do when it's arithmetic. The rest was entirely algebra. Okay, looking at the last part of this question then, it says the general term of another sequence is u of n is equal to n by n minus 2 factorial for all values of n that are greater than or equal to 2, and n is a natural number. Show that u of n plus 1 is equal, u of n plus 1 is equal to this, which is n minus 1 by u of n plus n minus 1. Right, the first thing I'm going to do is I'm going to find out what u of n plus 1 is if I use this formula and I replaced all the n's with n plus 1. So I'm going to do that first. So u of n plus 1 is going to be equal to, and I'm going to fill in, instead of n, I'm going to fill in n plus 1. Then I'm going to have square bracket, and then instead of n, I'm going to replace it with n plus 1. Okay, so I'm going to tidy that up as much as possible. So I'm going to have n plus 1 into this tidied up on the inside there becomes n minus 1 factorial. Okay, if I tidy this out by multiplying in my n plus 1, what I will get is I will get n into n minus 1 factorial, and then plus 1 multiplied by that gives me plus n minus 1 factorial. Now, straight away, what I see is I've got part of the question answered, so I've definitely got marks in the bag from here. Okay. What I also notice is that this piece over here, that is n by n minus 1 factorial. Well, actually, this could be written as n factorial. That's what that is. N multiplied by n minus 1 factorial. So if you had 4 multiplied by 3 factorial, that's actually the same as 4 by 3 by 2 by 1. And that is the same as just saying 4 factorial. So that's what I've used here. So that's just n factorial. Okay, so plus n minus 1 factorial. And I would like to show that n factorial is what you would get out if you multiplied n minus 1 by u of n. Well, yeah, n factorial is going to be n by n minus 1 by n minus 2 dot 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 dot. So it's by n minus 2 factorial, isn't it? And have a look at what I've just got out. So that, first I wrote it as n factorial, then I said, what does that actually mean? It means n by the one that came before it, by the one that came before it, by the one that came before it, and so on. But look at this. This and this piece together gives me the original u of n. So the green pieces together, that gives me u of n. And then it says multiply that by the remaining piece, which is n minus 1. And that's what they wanted. So it actually, again, very little to do with sequences and series, and a lot to do with algebra. So you had to understand what the factorial is there. So a nice little question. A lot more to do in that question with algebra than sequences and series.